think we are starting. Yeah, we are alive now. Finally, sorry guys. So we have some problems with the mission at the beginning, but finally we got it, and here we are. And PyData Salamanca, sorry for these 5 minutes, but you know, like the things that are good take some time, so that's why we are a little bit late. So with no further ado, I want to start because we are a little bit late. I'm going to start talking a little bit about PyData Salamanca. So you know a little bit who we are and what we do. So PyData Salamanca started 2 years ago in 2018. So we started with some little talks at the beginning, 3 years ago, and so after a while, you know what happens. Coronavirus came, and we changed everything from the normal meetings to these online meetings, and since then we are doing that. And so just to show you a little bit about this. So here we are, PyData Salamanca. These are the social media where you can find us. So we are posting every new meetup once in a while here in Twitter and Facebook, and we have all our talks, our last talks, and even the talk from today, we have it in our GitHub and PyData Salamanca. So if you want to check it, you can check it. There will be a little bit of changes about the specific.
Live streaming is on.
Okay, should I start?
I think we are back. Sorry. Okay. So I don't want to talk a little bit more about PyData because we have had a lot of problems with the broadcasting. So Nilufar, just proceed. Sorry.
Thank you very much, guys. Hi, I am delighted to have the chance to present for you today, and I'm gonna share my screen so we can start. Okay. Okay, so today we are going to dig a little bit into Twitter with my presentation, which is titled as an AI feature-based approach on behavior analysis of the users on Twitter. I'd really like to thank to PyData Salamanca group for holding this series of talks and their organization. Today we had some technical problems, but normally there is no problem, and I personally learned so many things by participating in their talks. Well, let's have a little introduction. Victor introduced me, but I'm gonna give you more details. My name is Nilufar Shoaibi. You can send me an email, or this is the link of my LinkedIn and Twitter. I'm a PhD student in intelligence system at the University of Salamanca, Spain, under supervision of Professor Juan Manuel Corchado. Apart from my studies, I am a researcher and developer in artificial intelligence at BCT Research Group. And my research interests are focusing on social media analytics, data science, artificial intelligence, machine learning, natural language processing, discrete mathematics, and graph analytics, and so on. Whatever is related to AI. But the outline of the presentation today, first of all, we will talk about a little bit background on what's social media analytics. And we are talking about the research areas and practical required information and knowledge, because I was thinking that probably there are people in this talk today in the audience that they have been working in this area for a long time. Also, the people who want to start doing the research about this topic. So I try to add some practical required information for the people who want to start from zero. And then we will continue with the proposed architecture and the case study of US election 2020. And then at the end, I'd be happy to answer your questions. Okay. What social media analytics? Social media analytics is the process of gathering and analyzing the data from social media platforms such as Facebook, Instagram, LinkedIn, Twitter, and so on. But it's truly the art and science of extracting hidden concepts from semi-structured or even unstructured data to enable informed and insight decision making. And also, it is crucial to do the social media analysis due to the flow of information which has been published through the users. I mean, each user can create a flow of information through the content that they publish by employing different content sharing strategies, and analyzing this information helps us to have a better understanding of types of users in order to meet their needs, to predict their tendency, and based on their behavioral categories. Okay, about the research areas, well, I've been working in this area, I think it's probably more than a year. So when I started, when I was doing my review paper, so I made a database of the recent works in this area, and then I made the semantic representation of the areas related to social media analytics. We have a machine learning category, which can be like classification models, like support vector machines, neural networks, and so on. It can be pattern classification, social networking, feature extraction, which is super interesting. We can use the information for designing the recommender systems. We can do the event detection, which we have another paper which is related to crime detection. Sentiment analysis, clustering, natural language processing, and graph analytics networks. But graph network analytics. But how I discovered this semantic representation is also interesting. I made a database of all the papers, practical papers that I was interested in them. And I made a database of a relationship between each paper and its own keywords. And then by reducing the least popular keywords, I reached to this graph, more sparse, and then based on this information, I made the semantic representation. Okay. So let's start the practical required information and knowledge. As I mentioned before, I want to try to cover the necessary information both for experts and the ones who want to start researching in this area. So for starting, first of all, the most important is to read the privacy and policies. Then the data publication policies. I'm gonna tell you how to build the Twitter app. What is the tweet object, which is the data that we are going to use in our analysis. And then I'm gonna talk about the data extraction methods. Okay, so first we start by with privacy and policy. Okay, the most important thing is the user's policy. When you start registering in a social media, it will ask you for some information, and then you accept the policy and privacy of the social media. For example, in Twitter, it is important to know what are exactly the information that you are sharing, because later a user shares, because later in the analysis it's necessary to know what kind of data we have. For example, in Twitter, there are some terms that is possible to be nullable. There are nullable terms. So for example, location is not required. When you are making a Twitter account, you need to put a name and a screen name for you, your email, and some other information. But the location by default is null. So, but if the user wants to put his or her location, she or he can put the location. So it's important to know these things for the further analysis. Also, it's important to know the forbidden content. For example, on Twitter, it is not possible to post about sexual harassment or child sexual exploitation, or I don't know, information about suicide, and like encouraging people to do the suicide and these kind of things. So it's forbidden. Why? Because Twitter has its own algorithms to find this content, and so fast, like this I know it because I was studying these things. These algorithms are so fast. So right after you publish something with this content, Twitter will suspend the profile. So it is so important to know this, to define the project in a way that is trustable, because you need to define your project based on the rules of the Twitter. So I put the important and useful links. For example, if we click here, just a moment. Okay, so this is the web page of the Twitter rules. If we scroll down, so it's not possible to make the violence content or terrorism, violence, violent extremism, or child sexual exploitation, and so on. Like, you need to read all these things so carefully. And I added the link so you have all to continue your studies. The next thing that is so important is the data publication policies. That I know it is the question of so many people, but fortunately, Twitter has documentation for everything. So if we go to this link, we will have all the necessary information for sharing the data. Like, it says that it's necessary to use official Twitter APIs. It's important not to use this data for the it's okay to use it for the research, but it's not possible to use it as a commercial means, and so on. Like, it's a long list that you need to read it if you are new to the to this field. And as you see, is all with the capital alphabet, so this is truly important. And the other thing that is so important is that constantly they change the policies, so you need to be updated a lot. Like, you need to spend a lot of time being updated in this field. Okay, let's continue. building the Twitter app. This is not difficult at all. You just need to, I added the link here, but I'm not gonna open it. You just need to log into your account and insert your information, and then explain why do you want to make the app and how do you want to use it. Is it for commercial? Is it for an enterprise? Is it for the study only? That's all. But this is the more interesting part. What is a tweet object? Tweet object is the data that Twitter gives us to deal with. So if I open it, and I have it here. Okay, so it's a data dictionary in the JSON file. Okay, but what we have inside, there are some root level information. This is all the necessary information. We have some root level information like created at, which is the time that tweet has been made, the ID of the tweet, the text of the tweet, the source, which is the for the web, if the tweet has been truncated, so it's a Boolean. And we have the second level, which is the user object, which contains all the necessary information about the user. So we have the ID of the user, which is a unique number. We have it as a string. We have the screen name, which is also a string name of the string unique name of the profile. As you see, it's not possible to have space here, but in the name you can have it. The URL, the location, the language, so many information. On the next, after the user object, we have coordinations, which contains latitude and the longitude of the tweet. And so on. Like all the necessary information that you need to deal with is inside this JSON file, and like you need to know exactly what is what kind of data, not what type of data, but what data, which information this social media is giving you to deal with. Okay. The data extraction methods. So recently, Twitter API launched his second version, but it's an early access. For example, this study that I'm going to explain to you is implemented based on the first version, the standard API mode. Like the premium and enterprise are too expensive. So we use the standard version, and for the data extraction methods, and I added the links. So if you want to study more, and because you need to study more about these things, you can click and read the documentation. The data extraction modes we can classify them into two categories. Like this is the category that I like to classify this way. It's possible to get the information on real time, which is by streaming the information. Also, it's possible to get the information by batching mode, which you can download a specific amount of data all in one time. But how do you make the queries? To make the high quality filters for getting a Twitter data, there are two types of operators. Standalone operators, which you can make your query, which can be a streaming or batching by keyword, which is a word that will be compared with the tokenized version of the tweets. You can search make the query by emoji. If you put your keyword in double quotations, you will have the search by the exact word, exact phrase. You can search by the hashtags. You can find the tweets which are mentioning a a person, because after this at sign, you need to write a screening. And tweets about the specific users, and so on. Like, there are so many different ways that you can make the query. Also, there are the second types are non-standalone operators, which is you can add them to the previous operators. For example, I want all the information about a subject that is retweet, is a quote, is verified, the account is verified, has hashtags, has links, has mentions, has media, and so on. And even you can filter based on the language. Okay, so now that we have the practical knowledge and information about how to start this, how to start the research in this field, let's start the model that we presented in our paper. So today, the talk is about an AI feature-based approach on behavior analysis of the users on Twitter. We published, this is one of the first steps of my research in this area, and we published this paper in 17th International Conference of Distributed and Computing and Artificial Intelligence, and it's published in Springer. And well, the following slides are a little more advanced than the paper, but I believe the paper is worth reading. So the challenges in this area is that all the environment is stochastic and dynamic, because we are dealing with people, and people are not easy to be predicted. And the second one, non-stability of the features, leading to not being able to have a proper data set. It is not possible to put a label on someone and say, okay, this person is an influencer. No, because due to the time, everything can change. The number of followers of the person change. The number of tweets a person make change. The meaning of high, like if we say, okay, high retweets, the number of high will be changed during the time. So it's so difficult to have a proper data set in order to use machine learning algorithms on them. But what is the solution for doing this? The solution, the first one, is to map the problem into the graph network environment and try to explore the problem with another aspect, with another point of view. And then the other solution is to extract secondary and more advanced features to have a better view of the users and the connections. And the third one is the different audience in different areas make various unique characteristics of users' categories. This looks a little bit complicated, but I tell you, I have an example in the next slide, but I can tell you, with one example, the influencer, which is the person who has a great influence on the audience, and people they are tending to share that person's content and engage, like his or her content are engaging the audience. This influencer in the area of art is totally different. The behavior, the audience, the numbers, all is different from an influencer in the area of, for example, politics. This is my example that I will tell you in the next slides. But for now, believe me that the influencer in art is different from influencer in politics by the characteristics they are showing, by the way the strategies they use to get the user engagement. And due to all these things that I explained, it's not being able, it makes us not being able to train the machine learning models as we can do for other problems. So these social media analytics problems are, I believe, a little, well, so different from other problems that are more easy to use machine learning, and like classification, regression models, and so on. So we have the example of influencer in art and influencer in politics. And let's see. This is a profile of an influencer in art, which is called New York Art Beat. As we see, this person has 212K followers, and the date that the user joined Twitter is on October 2008. As we can see here, we have this profile that we discovered based on our case study, that this person had a great influence on the people in the election of 2020, the US election. So as we see here, this person only has 8,000 followers, and he joined to Twitter on 2015. So this is maybe they have the same influence, but as you see, they are different. So if we go to his profile, we will see that first of all, this person is not retweeting from other people. He's posting his own ideas about any subject. And as we see, for example, the engagement of each tweet, the number of likes more or less are a good number, but the number of retweets are engaging. So this person is an influencer can be considered as an influencer in politics, but the one in art is totally different, by having a lot of followers and maybe more or less user engagement. Okay, let's talk about the proposed architecture. In our proposed architecture, after extracting information from Twitter, we will do the graph network analysis, which is converting the area of the problem into the graph network environment. And then we will try to extract the more advanced and secondary and more advanced features to have a better sense of the people. And then at the end, we can, based on all the information that we have about the graph, which is the behavior and relationship of the people, and based on the metadata, which can be considered as the characteristics of the profile, we can say that we can like suggest that this profile is an influencer or it's a fake. Okay, because I talked so much about data extraction, I'm not gonna explain more, so I'm gonna jump to the graph network analysis. For doing a graph network analysis, we need to define three important things: the nodes, the edges, and the weights of the edges. So in this case, we want to make a graph similar to this photo that I put here. So as the nodes, I convert nodes into the Twitter users, and the edges can be considered as retweets, quotes, or mentions. And the weights are the iteration of the two connections, of the connections between two nodes. So for example, if node A is mentioning node B or retweeting node B 3 times, the weight will be 3. After making the graph, based on this new problem that we have, we can measure, we can do some extra measures, which are, for example, centrality measures of the nodes. For example, eccentricity centrality, closeness centrality, betweenness centrality, in degree, out degrees, and degree centrality, which are are related to the centrality measures. For example, eccentricity centrality is the maximum shortest distance between distance of one node from the others. So the lower eccentricity centrality, the greater is the power of the node to influence others. Or closeness centrality, which indicates how close a node is to the other nodes in a network by capturing the average distance based on one vertex to another. Or betweenness centrality, that shows how influential the node is, and the greater value betweenness centrality is, the more important the node would be to the shortest path through the network. So if the node is removed, many connections will be lost. Like, they are so similar, the explanation is so similar to the name, so it's more between the other nodes. In degree, out degree centralities, in degree will be calculated how it shows the importance of the nodes via the number of edges that are entering the node, and out degrees, like its name, and degree centrality is the summation of the in degree and out degree. We have topology measures, which are in degree, out degree, and degree measures, which are kind of not for a normalized version of the centralities. And we have some function and algorithms that we can do. For example, has self loops. It means that in the graph that we designed in this problem, having a self loop means that I am retweeting from me. So if I have a lot of self loops, if the weight of my self loop is high, it means that I am retweeting myself so many times. It means that it's possible that I am a bot, because I want to make a more engaging post, so I'm retweeting myself so many times. And also, it's possible to do community detection algorithms like Gervan-Newman, like Leiden, and so on. It depends on the graph. If your graph is a directed graph, or if it's not directed graph. I implemented all these in Python using NetworkX library. And it's so easy. So here is all the information I explained to you in tables. In a table, so you have a better view if you want to study more. And well, let's jump into the metadata analysis, which is the next component. In metadata analysis, after we have from the tweet object. Okay, I forgot to say something. When we make the graph, it's possible because we go to each tweet and we try to find the people who have been mentioned in this current tweet. So it's possible to have the tweets, the usernames that are not making the tweet themselves. I don't know if it's getting too complicated or no, but at the end there are some users in the graph who we don't have any information about their tweet object, so we don't have any information of those users. So for this, we need to make another query. So let's think about the basic features that we have. We have basic features from the tweet objects. which is the screen names, the IDs, the information I showed you on in the web page of Twitter, the information of retrieved tweet, the number of likes, retweets, and replies of the tweet, the number of followers and followings of the user, and so on. But after this, we need to make a secondary feature. The secondary features, which we perform a new query for each profile, which who are the nodes of our graph. So we retrieve the last 200 tweets of the profiles. Oh, I forgot to say this too. Twitter API has some limits, so it's important. If you go to the web page, you can see all the limits. For example, the maximum tweets you can retrieve in 15 minutes is like maybe 900 or something. You need to check that. So anyway, after retrieving the last 200 tweets of the profile, each profile, we can have more complicated features like maximum tweets per day, like number of retweets, like number of tweets with URL, and so on. And also it's possible to create more advanced features related to the previous ones, which are mostly ratios, like ratio of published tweets and retweets, ratio of tweets per year, or even ratio of tweets per day, and the time gap between the tweets. So if you pay attention, we are trying to make the features that are similar to the time series, so we can map this. We can find solutions for this problem from the time series modes. Okay, so now we have the information from the graph, and we have the information about metadata analysis. So as we don't have any data set to tell us, okay, this person is an influencer, and because the concepts change, so we will do the feature-based study, and we will try to find related features to each category of the profile. So for example, we have the verified profiles, which are easy to be detected. These are the accounts which are officially verified by Twitter. It's simple to find them because in the user object, there is a verified term which is true, but finding influencer is a challenge. Let's have a short introduction that who are influencers. Influencers are people who are not verified by Twitter, but they have a great influence on others, and their content has an undeniable engagement, like the profile I showed you. They have a high number of their own tweets. They have a high number of followers. The low time between the tweets. For example, it's not like I am as an influencer make a tweet today and the next one is in 2 weeks. The high number of interactions with their own tweets. Interaction is related to the number of likes, number of retweets, and the number of comments. And then we can say they have a high in-degree centrality. Why? Because there are many people who are retweeting from their content. So if we imagine the graph, there are a lot of edges between other accounts going to this specific account. So based on, and these are some of the features that we considered. So based on this information, we can say that, okay, this person might be an influencer. Or for the fakes. Fakes are people who are not verified by Twitter, but their contents are fake news, spam, incoherent tweets, and so on. Like bots are another types of fake profiles. They have the high number of retweets, the low time between the tweets, some of them have default profile image, and some of them have no biography. And the numbers, there are like random numbers at the end of the account name. The small number of followers, it's for sure not so many people are willing to follow a fake account. It's interesting because if an account have 2001 followings, it means that this account is fake, because if you start following as a fake account, you start following people, and when you reach 2001 followings, you are banned to follow more people, and you need to wait for other people, for those people to follow you back. So if you see a profile with 2001 following, it's a fake. They have duplicated tweets, they have self loops, they have high out degree numbers, because they are trying to mention other people, but nobody is mentioning them. So the low in degree number. And the regular profiles are the profiles that are not belonging to the other three groups. They are people who are not verified by Twitter. They publish a few contents, favorites, with a balanced number of followers and following, not in a large number. And we have, as to sum up all, we considered 4 different categories of people. We explain a little about the characteristics of the profiles, and then we introduce some of the features we used for discovering, like for categorizing the users into the groups. And as the future work, we would like to add the real-time mode to this tool. And also we'd like to integrate other social media platforms. For example, right now we are working with the Telegram data. We want to use this user classification for further recommendation in different industries. For example, if I have a company that if I have, I don't know, a platform or something that I want to promote my company, I can use this tool to find influencers, and then by giving some offers to these influencers, I can use their tribute to promote my product or something like this. And also we are planning to find the features and find a way to generate reliable data sets to be able to use machine learning, as we can use machine learning in other fields. And thank you very much for listening, and if you have any questions, I'd be delighted to answer. And also, if you are interested in this field, I am open to collaborate, like scientific collaborations. You can send me an email or follow me on LinkedIn or whatever. Thank you very much, and that's all.
Thank you very much. It was a really great talk. Thank you.
Thank you.
As I expected. And sorry because we had some problems at the beginning of the presentation and a little bit. So just before I started with the question, I wanted to remember our sponsors, because I think it wasn't listened at the beginning. So just to tell you, we are part of Media USAL, who support us plainly, and also Cátedra Telefónica, who does all the things for us to have this nice group. And also we are part of NumFocus, who organize other PyData talks. I recommend you to follow other PyData meetings like PyData Berlin or PyData even. If you know other languages, there are some talks too. You can search for PyData in YouTube and you will find a lot. I'm sorry for that. That was just a little bit of an introduction. So we have some questions. I have another question too, or a couple questions, but I prefer the others to have this. So we have one question, but apparently the message was well. We have another question. So how does a correlation with other social media could perform? I think maybe they are talking about, I don't know, Facebook or Instagram, or if they are some similitudes. I'm guessing.
Yeah, and the reason that I was insisting on reading policies was because each social media platform has its own types of policies, and the information they are making available for the scientists to like do the research. There are not conflicts between like different social media platforms, but this is something that also there are some tools, like if you search data social media analytics tools, you will find a lot of websites and platforms that considering the information from different platforms to even find influencers and so on. But the thing is, their algorithms are because they are doing like it's industrial, is marketing, they are enterprises. They are not giving so much information about the like we don't know the algorithms. I even talked to a couple of them, but it's not possible to get information from them. But it's possible to correlate the like you need to define your model, you need to read the policies of different social media platforms, and you need to first define your project in the correct way. I hope they got
No,
it.
I think it's really well explained, because you had to do all this previous work to really correlate in between different social media. It makes sense. So I have a question, because I find your research really interesting. So when you were talking about the specific users, you were like clustering, and so this is based on a broad population, I guess. Did you experience something more specifically based on, for instance, this American elections? Like if these kind of clusters are related to this specific topic?
Well, to be honest, I don't know. By related, what do you mean?
Well, if you found, for instance, the same kind of clusters or different ones.
Like I told you about community detection algorithms. Like if you, after making the graph of the relationship of the people, if you perform the community detection algorithms, you can find the different communities who are having the same kind of same behaviors. They are, even if you study the content, maybe you can find the same way of thinking between them. For example, all of them are saying Trump is a bad person, or like this. Like we have other papers, but I cannot explain more because we haven't like got accepted yet.
I totally understand. It's something you have to keep for yourself to be published.
Yeah.
So I'm gonna check if someone has another question. Yeah, another question. How does Telefónica support your group? Okay, that is a specific question we have. So okay, we have Cátedra Telefónica, and Cátedra Telefónica makes all this. So they when the talks were like not like this, like online, we we have some backup from them to have, for instance, people that came from Madrid or Barcelona, so they pay for the hotels, and they allow us to do all this stuff. Like if we were just by ourselves, we could not spend that kind of money. So, but as I said, and I think you missed that, we had the chance to have Nilufer, who was in a meeting here in Salamanca last year, and she was the only one who didn't speak English, and that is something that in PyData we try to do we try the attendance to feel welcome. So it was me who tried to translate what the talk was about and everything. It was not perfect, but I think I did my best. And the good thing is Nilufer liked it, and we started to chat, and then she offered herself to give this talk, and this is what we try to find, people interested in sharing with us what they are doing. And for instance, this specific topic is really interesting, and we are lucky to have her. So I think I answered that question. That question was for me. So just the second question, and then if there are no more questions, we will end this. This is more a personal question. How frustrating is to deal with Twitter data?
Well,
Can be, I mean.
The more, it's not frustrating at all. I don't feel like it's frustrating. But the thing that is a little bit frustrating is that they change the policies so much. Like you need to be updated all the time. Maybe you have the permission to share this data. Next 7 months, next year, you don't have the permission. So these are well, I think every project has its ups and downs, but this is the cons. This is that are bothering a little.
Yeah. No, that's why you just started with that, which is a really good point. So okay, I think well, there are always a little bit of lag, but I don't see a lot of questions right now. So we are gonna end the transmission. Thank you very much, everyone, and I hope we will see you next meetup. I can tell you the next one will be in English too. And it will be at the beginning of December. So it will be about artificial intelligence in medical imaging. So it's a different topic, but also interesting. So thank you very much for everything, Nilufer, and I hope everyone enjoyed. Ciao. Bye.
Bye.